Hello, welcome to the video number 11 of the series Exploring ROS with a two-wheeled robot. In this video we're going to see two important things. The first one is about updating from ROS Indigo to ROS Kinetic, because this update was made in our system last week, and I'm going to show the necessary modifications to keep the ROS project working properly. And the second thing is that as I have changed from one version to another, I had to test many times my algorithms, so I had to develop and create another files to make it in an efficient way. Okay, so I'm gonna show these two things in this video. So let's start using ROS Development Studio as usual. If you don't have an account yet, you can create one and use the system for free, just following this link at the description of this video and click on the sign up button. As I have my own account already, I'm just gonna open my project and I'm gonna start from the previous project, because I'm gonna show the problems of the version and then I'm gonna show how to fix it. Okay, so let's open the project here and wait a few seconds. Okay, great, it's ready. So first thing, most important thing here is that we are using a gazebo plugin. Okay, let's take a look in our simulation workspace. We have the two-wheeled robot description. Inside the URDF file, we have this file here, gazebo, which is about the plugins we are using. So first thing here is that we are setting this legacy mode to false, and this generates a problem for us because the robot makes a confusion about between left and right side. So every time you want to turn to the left side, the robot's gonna turn to the right side, and the opposite. So the first thing here is that you have to change to true, or you can even remove this line, because that's the default value, is legacy mode equals to true. Okay, that's the first thing. And the second thing, let me launch the world here, have the simulation running, and you're gonna see a warning message when we try to spawn the robot, the same robot we have been working with, but now we have this warning because we're using ROS Kinetic, not anymore ROS Indigo. Okay, so now we have the terminal ready. So ROS launch, my two-wheeled robot, spawn launch file. Let's take a look here in the world and try to spawn the robot. So as you can see, we don't have any error, the robot's here, but we have some warning messages and it can be quite annoying. I don't like warning messages, and sometimes it can become an error. For example, next time we updated our ROS version, so let's handle it, let's fix it. The first thing here is that we have to use this new parameter here in order to process the chakra files. So this is quite simple to solve. We have only to add this instruction here to the launch file, spawn launch file, right here after the script we are executing to spawn the robot, to create the description of the robot. Okay. The second thing is that we don't have to use anymore the chakra.py script. Now we have to use just chakra. So you have only to remove the extension of the file here. Okay. And the final thing is that when you are working with chakra, now we have to use this chakra prefix before any chakra tags. Okay. You can use this script here that ROS is providing for us, and we can fix the files. So let's get into the simulation workspace and our package here. My two-wheeled robot description, URDF, that's the folder I have my chakra files, and let's execute the script ROS provided. Okay, and let's take a look in the modifications. That's why I love Git, because you can track the modifications. And basically the file that was changed is this one, macros, chakras. Let's check what have been changed there. Macros. And that's the modification. It was only added this prefix here before any macro instruction, macro tags, as you can see. Okay, and basically that's it. One last thing before we want to try to launch the robot again, to spawn the robot again. Let's open the files here because we have to add one more instruction in our tag, which is this one here, to inform to the XML file this is a chakra file. Okay, so we have to add here the same instruction we have in the main file to the other files. Let's do it and save all of them. Let's restart the simulation to have no robot there, and we're gonna try to install the robot and have no warning messages. Okay. In the meantime, cross launch, my two-wheeled robot, spawn. Let's put the position we have been working with. Okay, great, the simulation is ready. Let's check the initial position and let's spawn the robot. Wait a few seconds. Cross the fingers. And great, there it is. There is the robot and no warning messages anymore. So we have fixed the problem and now we have our project working with ROS Kinetic. Okay. So now about the efficient way of testing it, because until now we have been just restarting the simulation and spawning the robot again to have the robot in the initial position to try and to see the scripts working. So now what I have done here is to create a script to restart the position of the robot, and actually I'm spawning the robot every time that I launch a simulation, and I'm not restarting the simulation to have the robot at the initial position, and I'm gonna show how you can do that. This is useful not only for this project, but you can use for any ROS project. Okay, so in order to show that, I have modified many files. You can check all the modifications in the repository. We have it in Bitbucket. You can follow the link in the description of this video. That's the same repo we have been using since the beginning of this series. Okay, so instead of doing the modifications manually, I'm gonna only pull the modifications. So let's get into the package here, and I have no modifications here, so git pull origin master, and now for the simulation, but I have modified here manually to show you the modifications, the necessary modifications to make it work with ROS Kinetic. So let's just undo the modifications. Please be careful with this command. I'm only doing this right now because I have the modifications already done in a previous moment, and all my modifications are saved in the repository. Okay, so now I don't have any modifications here. Yes, let's reload the files. So git status, no modifications, and git pull origin master. Okay, great. Now we have the modifications. Yes, let's update the files. And now let's check what I have done here in the simulation. First thing is inside the My Worlds package, I have created one launch file for each world because we have been working with 3 worlds until now. We have an empty world, world 1, the second one to test bug 0, world 2, and the bug 0 foil, and the same world we have been working to show. We have been using to show bug 1 working, world number 3. Okay, and also to start working with a robot, bug 0, I'm using world number 2, and I'm also spawning the robot at the initial position we have been working with, y equals to h. Okay, and for bug 1, word number 3, and also spawning the robot at the same initial position. So that's the first thing that helped me a lot to test the modifications. So let's launch here, for example, bug 1, and we should have the robot already in the world using world number 3. Let's clean it. Okay, great. Now we have the simulation ready. Okay, I don't want to create an obstacle here. Let's delete it. Okay, and there is the robot. And now let's suppose you have been testing bug 1 or bug 0 or whatever, and you have the robot right here in this position. You don't want to restart the simulation and respawn the robot, so here it is what you can do. I'm going to show in the Jupyter notebook because this is a very easy way to test a Python script, and then I'm going to show how I did it in the code. So let's start notebook here. A new file, new notebook, Python 2. That's the version ROS works. So basically the service that I want to use is ROS service type. Is provided by Gazebo node, and it's called set model state because my robot's a model inside the world, and that's the service, the kind of service we have to use to set the model state. Okay, so first thing here is that inside my Jupyter notebook I have to import some libraries, of course ROS.py, and after that I have to import the service that I'm gonna use, so set model state, and it comes from Gazebo messages service, not message, this is very important, and the parameter that we have to send to the service is Gazebo messages message model state. Okay, so let's import it. Let's add a new cell here. We are gonna use, we have to set a service client, so service client set model state ROS.py. This is a service proxy object, and it's using Gazebo set model state service. Okay, and that's the kind of the service. Let's instantiate this object, and in a new line I'm gonna create the parameter, which is the model state. Okay, so let's take a look at the parameters here. I'm setting the position of this model here, my two-wheeled robot, and this name was given in our launch file. As you can see here, we are including my two-wheeled robot spawn. Let's take a look inside there, and here we have the node that is spawning the robot. We are setting here the name of the model, minus model, my two-wheeled robot. That's why I'm using here model name equals to my two-wheeled robot. And I'm setting the positions that I want to transfer the robot to, which is x equals to 0 and y equals to h. And the reference frame, you can just leave it empty. So let's erase it. Let's create the parameter. And finally, let's call the service. And there it is. So now the robot is in the initial position again. So you can do, you can set the position you want. Okay, you can change the value here and call the service again, and you can play with this every time you want to change the robot position without the need of restarting the simulation, respawning the robot, or even driving the robot using like a teleop package for that. Okay, so that's it. In this video I would like just to show how you can adjust your robot modifications from ROS Indigo to ROS Kinetic. This was a very important upgrade in our system, and this is how we can keep working with the same project, even changing the ROS version. Okay, and also an efficient way that you can use inside your script, so you can check in the repository, you can track the last commit, you're gonna see the modifications, and here you can see you're executing the same thing we have done in the Jupyter notebook. Let's put it side by side here. Hide the files. And we are doing the same thing here. So we are basically importing Gazebo messages. We are creating the service object here. So we are waiting for the service as we have to do for the other services. We are creating the service client. And finally defining model state object. Okay, so but now we are receiving an initial position that comes from a parameter in our launch file. And finally calling the service to change the position of the robot. So before finishing, let's see how it works. Let's see it working. So there, we have the robot right here, but we want to test bug 1, and the robot should start from here. So that's why we have our launch file inside the motion plan package, and we are defining the initial x and initial y. They are an argument, and also we have some default values here, so we can change it from your terminal or not. And after calling it, let's call ROS launch, motion plan, and bug 1 launch file. The robot must be teleported to the initial position, to the desired initial position, and start running bug 1 algorithm. So there it is. Great. This is how you can test effectively your algorithms without the need of respawn the robot, delete the previous robot, or even restarting the simulation. Okay, I hope it can help you testing not only this project here, but also another ROS projects. And that's it. I hope it can be I'm sure it can be very useful for you, because it helped me a lot to test the modifications in my package. And don't forget, if you like this kind of video, subscribe to our channel and press the bell to be notified about the videos we publish every day. See you!